the previous year questions from NEET 2023 exam. Okay, so first we'll start with the inorganic chemistry portion. Hello everyone. So in today's session we are going to discuss the previous year questions from NEET 2023 exam. Okay, so first we'll start with the inorganic chemistry portion. देखते हैं पहला क्वेश्चन क्या है. First question is, it says it is a assertion reason type question. It says metallic sodium dissolves in liquid ammonia giving a deep blue solution which is paramagnetic. Yes, this is correct, because when you have sodium metal and you dissolve it in the ammonia, it disintegrates like this. Okay, so it gives you the unpaired electron which gets attached to the ammonia. This is known as ammoniated electron. Okay, solvated electron this is. So whenever you have solvated electrons, they are going to give you the color in the species. Like this solution gets a blue color. Okay, and the reason it says the deep blue solution is due to the formation of amide. Yes, amides are formed in this reaction, but the color is not due to the formation of amide. The color is due to the ammoniated electron. Okay, so reason is incorrect, but the assertion is correct. So answer becomes A is true, but R is false. Okay, so this becomes your correct answer for question number 1. We'll go to next question. Next question is again assertion reason question. This says helium is used to dilute oxygen in diving apparatus. Yes, this is also correct, that when you use the diving apparatus, in that along with oxygen, helium is being mixed. What is the reason of mixing helium? Helium is mixed because helium is less dense than the oxygen. Okay, helium is less dense than the oxygen. So helium has high solubility in O2. No, helium does not have high solubility in oxygen. Helium has very low solubility in oxygen. It is just mixed to reduce the density of the gas. Okay, so what should be the answer? Again, assertion is true, but reason is false. So here also the second option is correct. We will go to next question. Ab kya question? Now we have amongst the following the total number of species not having 8 electrons. ठीक है, क्या बताना है? We have to tell which does not have 8 electrons in the valence shell. Now if you talk about ammonia, nitrogen has 5 plus 3 electrons from 3 hydrogens, so they have 8 electron in the valence shell. Talk about AlCl3, aluminium has 3 valence electrons, 3 from chlorine, 6 valence electron. BeCl2, beryllium has 2 valence electrons, 2 from chlorine, it has 4 valence electrons. CCl4, carbon has 4 and 4 will come from chlorine, so 8 electrons. Phosphorus, कितने वैलेंस इलेक्ट्रॉन है phosphorus में? Phosphorus has 5 valence electrons. So 5 valence electrons plus 5 from chlorine, it has 10 valence electrons. So count कर लो. Now count how many species does not have 8 electrons. 1, 2 and 3. Okay, so 3 species do not have the 8 valence electron in them. So answer becomes 3. अब carefully mark करना answer. Mark the answer very carefully. See, they are trying to trick you. They have put 2 at option 1, 4 at option 2 and 1 at option 3 and answer 3 at option 4. तो इस तरह से tricky थोड़ा सा question को बना देते हैं. They sometimes try to trick you. So be careful. Answer is 3 but option is 4th. Okay, so this is how you can do this question. चलते हैं अगले पे. We'll go to next question. चलो. Next question, this is from MOT. Molecular orbital theory. ठीक है. अब पूछा गया, they are asking you the correct energy of N2 molecule. ठीक है, किसकी एनर्जी बतानी है? You have to tell the correct order of N2 molecule. अब कोई भी molecule, any homodiatomic molecule you have, it starts from sigma 1s, then you will have sigma star 1s, then sigma 2s, then sigma star 2s. Okay, this order remains same during your homodiatomic molecules. Okay, I'm talking about homodiatomic molecules. Okay, after that when we reach the p orbitals, now you will have to see which molecule has been given. Nitrogen has been given. So if nitrogen is given, we know nitrogen undergoes sp mixing. ठीक है, nitrogen में sp mixing होती है. So if nitrogen has sp mixing, the order of your orbitals is like this. This is your pi 2px, this is pi 2py. After that you will have sigma 2pz, then pi star 2px and pi star 2py, and at the end you will have sigma star 2pz. Okay, so this becomes the order. So this is your 1s orbitals, these are from 2s, and rest is from your 2p. Okay, these are 2p bonding, these are 2p anti bonding. Now match with the order. So first it should start from sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, all have same order. But after that you should have pi 2px equal to pi 2py. So see, here you have pi 2px equal to pi 2py. After, no, this cannot be the answer, because after sigma star 2s they are writing sigma 2pz. Here also yes, so all three options have pi 2px equal to pi 2py. After this you should have sigma 2pz. So here is sigma 2pz, after that pi star 2px, pi star 2py, and sigma star 2pz. So this becomes your correct answer for this question. Okay, so the correct order of energy of molecular orbital in N2 will be this, given in the option 4th, as represented by this molecular orbital diagram. ठीक है बच्चों, चलते हैं अगले क्वेश्चन पे. नाउ विल मूव टू नेक्स्ट क्वेश्चन. अब ये किससे है? ओके, दिस इज फ्रॉम योर पी ब्लॉक केमिस्ट्री. इट सेज you have to match list 1 with list 2, okay, with their uses and their properties. So you have coke, diamond, fullerene, graphite. ठीक है? So coke means carbon only. Okay, carbon in the form of coke is used as a reducing agent. Okay, what is the purpose of this? This is used as reducing agent. So I'll write here A should be matched with 3. Then you have diamond. Okay, what is difference between structure of diamond and graphite? Okay, diamond has your sp3 hybridized carbon atoms. Okay, and they attain the tetrahedral geometry. So diamond has sp3 hybridized. So this I'll write B here. Then you have fullerene. Fullerene we know it is a cage-like structure. So where is cage-like molecule? So this should be C. Then we are left with graphite. Graphite has one unpaired electron present, okay, which helps in acting the graphite molecules as lubricant. Okay, and there is some the layers are present in the graphite and they slip over each other. Okay, the slipping of layers in the graphite helps in behaving as the lubricant. So I'll write D here. So we have A should be 3, B should be 1, A3, B1, C4 and D2. So this option second becomes the correct answer for this question. Okay, now we'll go to next question. Next question says the element expected to form largest ion to achieve the nearest noble gas configuration. तो सबके ion लिख लेते हैं. We'll first write the ions of each and everything which can give you a noble gas configuration. So oxygen can give you noble gas configuration in O2 minus. Sodium can give it in sodium positive. Okay, N can give in N3 minus, and fluorine can give as F minus. Now see these species. This is a question of isoelectronic species. Okay, you have to compare the ionic radii of these isoelectronic species, and we know how to compare the ionic size of isoelectronic species. More number of protons, smaller is the size, and lesser the protons, bigger is the size. So you have to tell the largest ion. So you have to look for minimum number of protons, minimum atomic number. So here the minimum atomic number is of nitrogen. So nitrogen will have the highest ionic radii. Okay, amongst these the ionic radii of nitrogen is maximum, N3 minus. Okay, so this is how you can do this question. Okay, going to next question. Now this says taking stability as the factor, which one of the following represents correct relationship? Okay, so you have to tell which is more stable. So now they have given you the halides of group 13. This is indium iodide. So in this, indium is in 3 positive, here indium is in 1 positive, here aluminium is 1 positive, here aluminium is 3 positive, tellurium 1 positive and tellurium 3 positive. There tellurium 3 positive more stable than tellurium 1 positive. Okay, 4 options are given. Now this question can be solved by using the methodology of inert pair effect. Okay, you should remember what is inert pair effect. Inert pair effect says going down the group, the stability of lower oxidation state becomes more. Okay, because the s electrons are unable to take part in the reaction. S electrons reaction में participate नहीं कर पाएंगे. So the lower oxidation state will become more stable, but in the case of only your bottom atoms. So like you have here boron, aluminium, gallium, indium, thallium. Okay, so this member, only this member has the ultimate effect of inert pair effect, and the lower oxidation state becomes more favorable than the higher oxidation state. So tellurium 1 positive will be more stable than tellurium 3 positive. Others will have their 3 positive oxidation state more stable. So this becomes the answer, where it is tellurium positive is more stable than tellurium 3 positive. और कौन सा concept use किया? We have used here inert pair effect. Remember this. ठीक है, inert pair effect पढ़ लेना ध्यान से. This is going to help you a lot in the exam. आ जाओ next पे. Okay, so next question says intermolecular forces are forces of attraction and repulsion between interacting particles that will include. Okay, so you have been given 5 different forces and you have to tell which of the following is intermolecular force and which is not. Okay, so dipole-dipole interactions, yes, they are a type of intermolecular force. Dipole-induced dipole, yes, dipole-induced dipole is also a type of intermolecular force. Hydrogen bonding, yes, hydrogen bonding is the strongest intermolecular force. Covalent bonding, no. Covalent bonding is not used for the interaction between two different molecules. Okay, it is an intramolecular force. Okay, it helps in the formation of a molecule, but two molecules cannot have a force of covalent bonding between them. So this is not an intermolecular force. Dispersion forces, these are your van der Waals forces. Okay, so these A, B, C, E, all 4 are intermolecular forces. Covalent bonding is not a intermolecular force. So now which option is correct? A, B, C, E. Look for A, B, C, E. Here you have A, B, C, E. So this becomes your correct answer. We'll go to next question. Amongst the following options, which of the following molecules ions act as Lewis acid? ठीक है, अब Lewis acid क्या होते हैं? What are Lewis acids? Which do not have 8 electrons in their valence shell, and this is the most easiest question you can have. Okay, so if you talk about H2O, 2 electrons from H, oxygen is going to get 6 electrons are available with oxygen of itself. So 6 plus 2, 8 electrons. Okay, so H2O is not a Lewis acid. Now you have BF3. BF3, boron has 3 of its own electron, 3 electrons it is going to get from fluorine. So it has only 6 electrons. So BF3 becomes the correct answer for this question. Okay? It has 6 electron in the valence shell only. So it is a Lewis acid. Okay, others also you can check. You'll get exactly 8 electron in the valence shell. अगले बार आ जाओ question पे. It says the right option for the mass of CO2 produced by heating 20 gram of 20% pure limestone is. चलो अब निकालना क्या है यहाँ पर? See, ultimately you have to find the mass of CO2 produced. Reaction is calcium carbonate when heated gives you calcium oxide plus CO2. Okay, so if you know the amount of calcium carbonate, you can tell how much carbon dioxide is formed. So how much calcium carbonate has been used. 20 gram of calcium carbonate has been used, but see carefully, it is only 20% purity. It has only 20% purity. So, इससे क्या पता चलता हमें? Okay, if 20% purity says that in total 100 grams, there will be only 20 grams of your calcium carbonate. Other 80% is impurity. So total amount is 20 grams. Total amount is 20 grams and it is only 20% pure. So we'll multiply it with 20%, 20 by 100. This is going to give you 4 grams. Okay, so the mass of calcium carbonate used is only 4 grams, not 20 grams. Okay, so now if it is 4 grams, so moles of calcium carbonate, number of moles of calcium carbonate, it is the given mass divided by molar mass. Okay, the molar mass of calcium carbonate is 100. So it becomes 100 gram per mole. Okay, it comes out to be 0.04 mole. Okay, the moles of your calcium carbonate comes out to be 0.04. And now see, 1 mole of calcium carbonate is going to give you 1 mole of carbon dioxide. So if it is being used 0.04 mole, you are going to get 0.04 mole of carbon dioxide also. Okay, and if you are getting this much moles of carbon dioxide, so mass of CO2 formed, this can be given by 0.04 into its molar mass. Molar mass is 44 for CO2. Okay, molar mass will be 44 for CO2, and the answer on multiplying this 44 into 0.04, you will be getting 1.76 grams. Check the option. First option is correct, 1.76. Okay, so this is how you can solve this question. Okay, so now we have done this much question. We'll do one more final question of the day. Now this says which complex compound is most stable. Okay, you have to tell which of the following is most stable. This belongs to the topic of coordination chemistry. Okay, now what they are asking? They are asking you the stability of the compound, which is most stable. Okay, so here the stability of compound is increased if you have more chelation. Okay, and chelation can be given to you by the higher density ligands, didentate, tridentate, polydentate ligand. So look for those type of ligand. Now here you have ene present. Okay, 2 ene are present here, which is a bidentate ligand, and it can do cyclization in the compound. So if cyclization means chelation, cyclization is occurring, that gives the stability to the compound. So this compound will be most stable among these. Okay, so this was enough for today. We'll meet in the next session. Thank you everyone.